If you're a parent trying to figure out what coding languages your child or teen should learn in 2026, you're probably getting wildly different advice. Some people say kids should start with Python immediately. Others say AI is making coding obsolete. Some schools are still teaching Scratch. Others are throwing students into Java or C++ way too early. So what should kids actually learn? And more importantly, what skills are going to matter in a world where AI can already write software? Over the last 12 years, my company CodaKid has taught more than 100,000 students in over 100 countries coding, game development, and AI. And after watching thousands of students succeed and struggle, I think the roadmap is becoming much clearer. In this video, I'm going to walk you through the best coding languages for kids and teens in 2026, what I would start with at different ages, which languages are overrated for beginners, and how AI is changing what students actually need to learn. One of the biggest misunderstandings that parents have is thinking the most important thing is the language itself. It's not. The real goal is helping kids develop computational thinking. Things like loops, variables, conditionals, functions, event listeners, logic, debugging, problem solving. These foundations are absolutely critical, especially in the age of AI. Because yes, AI can generate code incredibly fast now, but if students don't understand the foundations of software, they won't know whether the code is correct, how to fix broken systems, how applications connect together, or how to guide AI effectively. The future is not going to belong to people endlessly memorizing syntax. AI will increasingly handle much of that. The future does belong to people who understand systems, architecture, understand product creation, and know how to collaborate with AI tools. And that's why coding still matters tremendously, arguably more than ever. For younger kids, I still strongly believe block-based coding is the best place to start, even in 2026. At CodaKid, we still love Scratch, beginner-friendly block coding tools and platforms like mCreator for Minecraft modding, because block coding teaches foundational concepts visually. Kids can actually see loops running, conditions triggering, variables changing, events firing, and that visual feedback is incredibly powerful. And honestly, Scratch is still fantastic. Our own daughter moved into text-based coding years ago, but she still revisits Scratch today. She still creates projects, she still posts games and animations, she still has followers there. Because Scratch isn't just educational, it's creative. And for many kids, it's the first time they realize, wait, I can actually build things. And that moment matters enormously. Once students understand the basics and can independently create projects in Scratch or block coding, that's usually the right time to move into text-based programming. Not based on age alone, based on readiness. And this is where I think that there are two really strong approaches. So the first is following student interests. The second is focusing directly on future-proof technical foundations. And honestly, I think the best pathways often combine both. For many younger students, motivation is everything. If a child loves gaming, game development can become a vehicle for learning programming. That's why we love Roblox Studio with Lua, Python with Pygame, and Minecraft modding with mCreator and eventually Java. Personally, I think Roblox Studio is one of the best introductions to text-based coding available today, because Lua is approachable, readable, relatively simple, and highly rewarding for kids. Students can quickly build custom weapons, abilities, animations, multiplayer systems, inventories, entire game worlds. And because Roblox is multiplayer, students are often dramatically more motivated to keep learning. The same thing happens with Python and Pygame. Python is another fantastic beginner language because it reads very similarly to written English. Students can quickly build games, automations, simulations, apps, and eventually AI projects. The key is engagement, because kids who enjoy coding stay with it longer, and consistency beats intensity almost every time. The second approach is to focus more directly on the languages that will matter most in the AI era. And in my opinion, the biggest ones are Python, JavaScript, HTML, CSS, and Node.js. Python is probably the single most important language for students today because it powers AI, machine learning, automation, data science, scripting, and a huge amount of modern software tooling. It's also beginner-friendly and incredibly flexible. But equally important, students need to understand the web, because AI is increasingly being used to build web applications. And that means kids should eventually understand HTML, CSS, JavaScript, front-end development, and back-end architecture. Also, APIs, databases, and automations are hugely important. Even if AI writes much of the code, students still need foundational understanding of how systems work together, because modern software development is increasingly about orchestration, connecting AI tools, automations, APIs, databases, front ends, back ends, and external services together. This is one of the biggest shifts happening in technology education right now. Some people see AI writing software and conclude kids won't need coding anymore. I completely disagree. In fact, weak foundations may become even more dangerous in the AI era, because students can now create broken applications incredibly quickly if they don't understand what's happening underneath the surface. So for example, if a student is building an AI-powered web app and the layout breaks, it's incredibly helpful to understand HTML structure, CSS styling, responsive design, and JavaScript behavior, so they can guide AI effectively. The same thing applies to APIs and automations. Students increasingly need to understand how systems communicate, how authentication works, how data flows, and how different software tools connect together. You don't necessarily need kids memorizing syntax for 20 years anymore. AI will increasingly handle much of that. But students absolutely need enough understanding to think logically, debug problems, evaluate AI-generated code, and understand what's happening underneath the hood. One thing I would personally avoid is pushing younger students too quickly into very difficult languages like C++ or even Java. Now, to be clear, these are excellent languages. They absolutely have value. But they often introduce unnecessary frustration for beginners, especially younger kids. I would much rather see students master one higher level scripting language first, build confidence, create real projects, and genuinely enjoy programming. Then later, if they want to pursue advanced engineering or computer science, they can move into lower level concepts. Another language we really like after Python is C#, especially with the Unity game engine. Unity is fantastic for students interested in 3D game development, simulations, interactive experiences, and more advanced software projects. And C# is a nice bridge language because it's structured and powerful without feeling quite as overwhelming as some lower level languages. A lot of students thrive there. Over the years, we've generally seen the strongest results when students follow a progression, something like this. For elementary students, start with Scratch, foundational coding concepts, creativity, and computational thinking. Then transition into Python basics or another beginner-friendly text language. For middle school, you can do an accelerated Scratch course and then move quickly into Python. From there, students often branch into areas that match their interests. Some become game developers using Roblox, Minecraft, Python, or Unity. Some focus on modern software engineering and automations. Others move into web development with HTML, CSS, JavaScript, and React. And increasingly, many students are learning how to use AI as a code partner to build real-world applications. Then eventually, the more advanced students begin building shippable AI apps, startup-style products, portfolio projects, and real software that they can share publicly. And honestly, that ability to build real things is becoming one of the most valuable skills students can develop. I think one of the biggest misconceptions right now is that the future belongs to students who memorize the most syntax. I don't think that's true at all. The future belongs to students who can solve problems, think creatively, understand systems, communicate ideas, use AI effectively, and ship real projects. That's the new advantage, especially now that AI dramatically lowers the barrier to creating software. The students who stand out in the future are not going to be the ones saying, I took coding classes. They're going to be the ones saying, I built this. Here's the link. Here's the game. Here's the app. Here's the AI tool. That is where everything is headed. So if you're a parent wondering where your child should start in 2026, here's the short version. Start with foundations, keep coding fun early on, follow interests, transition into text-based coding, learn Python, learn web fundamentals, understand how AI and software systems work together, and most importantly, build real things. If you found this video helpful, let me know in the comments. Thanks for watching, and I'll see you in the next video.